x squared plus 49 over x.
Everything over x.
Yeah, everything over x.
Okay.
And then finding everything like vertical asymptote.
Excellent. Excellent. So the first thing I'm going to do, I'm going to separate. Why? Because the denominator is one term. If you give me plus 1 here, I cannot do that. But you only set x in the denominator. So I want to make my life easier. Quickly. So I also see that the degree at the top is 2. And the bottom is degree 1. Well, this must have a slant asymptote. I know that for sure. Because the degree of the top is exactly by 1 unit higher than the degree of the bottom. So now I'll separate it. So I have x squared over x plus 49 divided by x. I simplify, of course, so it's x plus 49 over x. I already have the slant asymptote. Okay, I go back now to find everything. So it's f prime of x, then f of x, and the second derivative. Please stop me anytime, okay? You know that. Can anyone help with the domain?
Isn't it negative infinity to positive infinity?
It's a rational function, and we know that rational functions are not friendly functions. They could be undefined. And because it's a rational and because it has a denominator that could be 0, because again, I don't want to change that, but if the denominator were x squared plus 1, I would have had to agree. It's all real numbers because x squared plus 1 could never be 0. But the denominator is x, which means that this function could be undefined at the factor doesn't go away. I know for sure this is a vertical asymptote. Do we agree that the function, do we understand, everyone? Is that a yes? No?
Yes.
Okay, perfect. So at this point, I need to find x and y intercepts. Well, the function is undefined at 0, so I cannot plug in 0. At the same time, I want to find when f of x is 0, none. How come? Because I have x squared plus 49 over x. A fraction is 0 only if the top is 0. But x squared plus 49 could never be 0, no matter what you plug in x. This is always a positive number. So there are no x and y intercepts. Good. In that case, I can only determine this, 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 and this. There is nothing else I can find about the function from the function itself. When I finish these 4 limits, then I go to the first derivative and then the second derivative. Okay. So I will write y equals x slant asymptote. And I will find the limit, which is obvious. So when I find the limit when x approaches infinity, this will approach 0. But I'm going to write it. And this will follow the slant asymptote. It must be negative infinity and positive infinity. It must be. Because when I graph the slant asymptote, I graph it like this. And the function must follow the slant asymptote. So it has to have here negative infinity, like y equals x does, and here positive infinity, like y equals x does. Let's say we don't observe that, we don't notice that. So I don't want this device to die on this one because it's recording. So limit as x approaches negative infinity, and I prefer the second form. Just very clear, this approaches 0. 49 over infinity is 0, and when x approaches negative infinity, this is negative infinity as expected. And when I have x approaches infinity, the other limit will be infinity, as expected. So that is done. Now I need the limits left and right. of x equals 0. Okay. Limit as x approaches 0 from the left, from x squared plus 49 divided by x. I know that the top is positive, no matter what I plug in, and the denominator is 0. In this situation, I know there is no hope. It's either positive infinity, negative infinity, or DNE. There is no limit here. But 0 from the left will be a negative number, so obviously this is negative. And the other one, with x approaches 0 from the right, from x squared plus 49 over x, the same thing, but now it's positive over positive, and it's done. So that's all I can discover. I cannot discover anything else about the function. And by the way, there is no function that connects negative infinity to negative infinity. It has to come to a maximum. There is no such thing. How can it connect negative infinity to negative infinity? Like a straight line? No, it has to do this. There is no function connecting positive infinity to positive infinity. It has to do this. It has to come to a minimum. Okay, so let's discover that slowly. So now I'm going to find the first derivative. And I will differentiate this. So our function now, x plus 49 over x. And when I differentiate, I get this is 1. And this is negative 49 over x squared. I find the least common denominator to be x squared, and I need to multiply the top by x squared. So x squared minus 49. Nice, because it can be 0. It can never be undefined. It will be undefined at 0, but so is the function. So no critical numbers coming from f prime being undefined. But I get x equals plus or minus 7. You can factor, or you say a fraction is 0 when the numerator is 0. Or you factor, that's one way. Or you take 49 to the other side and take the square root, and that's still the same thing. So negative 7, positive 7, 0, 0. I need to study the sign of the first derivative. And also plug in the function negative 7 and 7. So when I plug in negative 7, I still have 49 plus 49 divided by negative 7. And when I plug in 7, I have 49 plus 49 divided by 7. So let's do that first. We can do this with the calculator, but I don't need to. So it's 2 times 49 divided by negative 7. Of course, I will simplify, and I get negative 14. And the other side will be 14. So negative 14 and positive 14. Okay, now I'll study the sign. And the first derivative, I'm going to write it one more time so I show you what I'm doing. Time of x, do not die on me. Oh, no, please. I'm not sure. I think every time I touch the pad, that's what it is. It just turns off by itself. Sorry. So this is x plus 7 and x minus 7 divided by x squared, of course. So the denominator is always positive. I don't care for it, and I'm not going to even look at it. So the sign is given by this. So at the top, I can plug in 0, and when I plug in 0, I get negative. When I plug in 10, I will get positive. When I plug in negative 10, I will also get positive. And now the moment of truth. I need to make sure that these two work well together. If they don't, I have to go back and check my calculations. From negative infinity, it goes up to this. Yes, of course, that's correct. From negative 14 to negative infinity, yes, that's correct. From positive infinity to 14, yes, that's correct. From 14 to infinity, that's correct. So it looks fine so far. Now the second derivative. And the first derivative, I'm going to use this, of course, not any fraction or anything else. So the first derivative was how do I move this? Let me see if I can move this further back. Because it turns off by itself. And I have to check every now and then. I have to look and see if it's recording. My apologies. Okay, so we had 1 minus 49 over x squared, or 1 minus 49 times x to negative 2. This is what I'm going to differentiate. So the second derivative, this is 0. I bring down negative 2, so 49 times negative 2, I think it's 98, correct my numbers, and x to negative 3. So this is 98 over x to the third. We already know the answer. So this is never 0. We already know the answer because since it comes from negative infinity, it goes to, of course, this is a local max, and this is a local min. So, right, so the first derivative, the second derivative has to be negative in this area. This one has to hold water because it has a minimum, so this has to be positive here. Let's check. When x is to the left of 0 or negative, this will be a negative number. Of course, it makes sense because it has a local max here. When x is a positive number, of course, it makes sense. It's positive. It has a local minimum, so it has to look like this. And the function is symmetric, so I have to mention that. And let me refresh your memory on symmetry. For even functions, f of negative x is the same with the function. So if I have x in the function or negative x in the function, it makes no difference. An example. For example, f of x equals x to the fourth plus 2x squared. If in this function I replace x by negative x, nothing happens. It's the same function. So this is an even function, which means symmetric with respect to the y-axis. Symmetric with respect to, that's how lazy people write it. It's easier for me to write. So WRT, with respect to the y-axis. For odd, the relationship is similar, but opposite here. So negative x is negative f of x, and this is our function. So if I replace x by negative x in our function, this will not change. This will, of course, not change, but this will. So it will be x squared plus 49 divided by negative x, and I'll bring the negative in front. And this is exactly it, the opposite of the original function. So our function is odd. So it's an odd function. This is the only thing that does not fit in the table. I have to write it on the side. So how will an odd function look like? And then we'll graph it. As an example, I'm going to give an example here for both. How an even function looks like and how an odd function looks like. So an even function, that's not a good color for this. So let me do green. This is an even function, like x squared, for example. And this is a odd function, like x cubed. And now we're ready to graph the function that you came up with, a very interesting one. I have to first graph the asymptotes. This is an overkill. I will not graph it again because it happens to be the y-axis. But I do have to graph the slant asymptote, which is y equals x. And I know how it looks like. It's the line that bisects the first and the third quadrants. They're not part of the graph, the asymptotes, so they have to be graphed not as solid lines like dashed lines. Okay, I have to plot this point, -7, -14. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4. And exactly opposite, on the other side of the origin, I have, of course, 7, 14. Okay, ready? function is coming from negative infinity, increasing to the local max, dropping to negative infinity, so increasing and decreasing, negative infinity on the left-hand side of the vertical asymptote, all the time opening up. No problem. Asymptotically to the asymptote, asymptotically to the asymptote. And we know this point. Same thing on the other side. Approaching the asymptotes. That's why they're there. That's their meaning. And this is our function x squared plus 49 divided by x. If you want to graph this with a graphing calculator, make sure that you put in the slant asymptote because the calculator doesn't know it. It will not graph it. Please remember to put parentheses around the top. In this case, I will not put parentheses around the denominator because there is only one term. Otherwise, I would have. And the second function has to be y equals x. Don't rush to hit graph because we have to adjust the viewing window before I hit the graph so I can see this. So I will go to the left, maybe negative 10, 10. That will be okay. But up and down, I will go much higher. Let's say maybe positive 30, negative 30. So go to the viewing window. X minimum, negative 10, 10. That would probably, oops, negative 10. Negative 10, enter, 10, enter. That could be okay with a scale of 2 maybe. But the y minimum, I'm going to say negative 30 to 30 with a scale of 5. I can adjust later. Let's see what we get. Here it comes. Here it comes. And here's the slant asymptote. If you want to try to determine that minimum, you know the answer. We can go to second and calc. I want a minimum, and I know it's between positive 1 and 10. So I'm put 1 and 10. I don't have to do this. I do it with all the other classes other than calculus because you know how to determine it, but algebra classes don't know that. So I have to do this with them. Okay, so you see there is a tiny error or a tolerance of the calculator. It gives me 7.6 zeros and 6. No. Be careful. You know more than the calculator does. You know that that's incorrect. I don't know if you get the same type of error that I do, but there is no such thing. If you plug this in, you're not going to get that. So be careful. Calculator is not perfect. Thank you for this problem. Thank you. Good. Next question. Anything else?